Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Question 4. What's meant by monochromatic light? A laser produces a beam of monochromatic light. Can you tell me, guys, in the comments, what do you mean by laser? What do you mean by monochromatic light? Light of single color. It has one single wavelength, one single frequency. So monochromatic means light of single color, one, or it has single wavelength and single frequency. Okay, now we have a wave in air is incident on a glass block, showing wavefronts in the boundary between air and glass. What happens here? The wave undergoes reflection and refraction at the air glass boundary. Draw the wavefronts of the reflected wave and the refracted waves. Let's start by reflection. You have to extend the direction of wave travel here. I will draw another one parallel to the first one. Okay. Reflection, so the wave will obey the law of reflection, which is angle of incidence should be equal to angle of reflection. You have to draw normal. Okay, so angle of incidence should be equal to angle of reflection. So this angle is the angle of incidence. So you will not draw the reflected ray like this or the direction of reflected wave like this or like this. You have to draw the reflected ray or the reflected wave angle of incidence should be equal to angle of reflection. It's not clear. Still, we didn't draw wavefronts. Wavefronts are perpendicular to the direction of wave travel. So here, this will be, this is the direction of the reflected wave, direction of the reflected wave. Okay, so here you will draw wavefronts perpendicular to the direction of wave travel. Okay, guys, check. These are wavefronts, so they are perpendicular to the direction of wave travel. Let's move to the next part, refraction. How wavefronts will be refracted. We have here the refraction. From air to glass, what happens according to wave equation? According to wave equation, the frequency is constant. What happens to speed and wavelength? The speed decreased and the wavelength decreased also, becomes shorter. So when you draw wavefronts, you have to make sure the wavelength becomes shorter. Okay, so now this incident, the direction of wave travel, it will not continue in the same straight line. It bends towards the normal. Okay, and this will be the direction of refracted wave. Okay, I will draw the wavefronts here in yellow, perpendicular to the direction of wave travel, but the wavelength will be shorter. It's clear here that the wavelength is shorter than in the incident here, the incident wave. So the wavelength becomes shorter and you have reflected wave and you have refracted wave. Partially reflected, partially refracted, but most of the waves are refracted. Is it clear? So we have here, this is the normal. Some of the rays or the waves are reflected. This is the angle of incidence. This will be the angle of reflection. Okay, but here this angle is the angle of refraction. We have here the direction of refracted wave and we have wavefronts of refracted waves. This question is challenging and is very important.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.